Pi is 3.14159265, but you came here for Pocket Ronnie, so please stay tuned.
In Appendix B, that's a review of special triangles. One of the first special triangles you learn about is a 45, 45, 90 degree triangle. So that's what this looks like. So since one of the angles is 90 degrees, it's still a right triangle. If this is 45 degrees, the other one has to be 45 degrees, because remember, all the angles have to add up to equal 180 degrees. So if this is 90, these two have to equal 90. 90 plus 90 is 180. So if this is 45, that has to be 45. They might not label it, but just know if that's 45, the other one's 45, and it's a special triangle. So it's a 45, 45, 90 triangle. Okay, in a 45, 45, 90 triangle, it is an isosceles triangle. So if the angles are the same, the sides across from those angles are the same. And so these are the legs. So we're going to label those as A. So in a 45, 45, 90 triangle, your legs are the same. Then the hypotenuse is whatever the leg is times square root of 2. And this is how we will symbolize the picture of a 45, 45, 90 triangle. This just represents that the legs are equal, they're the same, and your hypotenuse is whatever the leg is times square root of 2. Okay, looking at on page B1, problem number 12, you have this right triangle. This shows us that it's a 45, 45, 90 triangle. So in a 45, 45, 90 triangle, our legs are the same. So if this leg is 15, this leg has to be 15. So B equals 15. I don't have any units, so I'm not writing any units. So if that is 15, then my hypotenuse is whatever the leg is, 15 times square root of 2. Nothing else to simplify that. There's no other, we don't need to simplify that. And I'm not going to turn it into a decimal. If I did, it'd be square root of 2 and then times 15. I'm just going to leave it like that. Okay, still on page B1, looking at problem number 3. Here, we're shown 45, 45, 90 triangle. So in a 45, 45, 90 triangle, our legs are the same. So if this is 3 square root of 2, this is 3 square root of 2. So I know that A, scoot over. I know that that leg is 3 square root of 2. So this one is 3 square root of 2. My hypotenuse is whatever the leg is, 3 square root of 2 times square root of 2. You have to keep up with your radicals. This is your leg. Then you multiply by the square root of 2. So 3 square root of 2 times square root of 2, numbers to numbers, radicals to radicals. So it would be 3 times square root of 4. Square root of 2 times square root of 2 is square root of 4. Keep simplifying. This means 3 times square root of 4. 3 times square root of 4 is just 2, which is 6. So turns out our hypotenuse is 6. Keep simplifying until you can't simplify anymore. Okay, now look on page B2, problem 4. So in that problem, at the top of the page, they're going to give you a triangle to where A and B represent the legs, H is the hypotenuse, and then they have this as theta and alpha. And in this specific problem, on problem number 4, they tell you that theta is 45 degrees and that the hypotenuse is 5 square root of 2. Okay, so since we know this is 45 degrees, alpha also has to be 45 degrees, which this means this is a 45, 45, 90 triangle. In a 45, 45, 90 triangle, our legs are the same, and then our hypotenuse is the leg times square root of 2. Well, here we're given the hypotenuse, so how do we go backwards? So to go backwards, going back up to this diagram here, if you're given the hypotenuse of A square root of 2 and you want to get to the leg, how did we go from here to here? If you're given the hypotenuse, you can divide by square root of 2. To go from leg to hypotenuse, we multiply. So now to go from hypotenuse to leg, we divide by square root of 2. Because if we took A square root of 2 and divided by square root of 2, those would cancel and we would be left with A. So when you're given a hypotenuse, you can take your hypotenuse and divide by square root of 2, and that will get you over to the leg. So going back to the problem that we have, we're given the hypotenuse of 5 square root of 2. So if we took our hypotenuse and divided it by square root of 2, that should give us the legs. Our square root of 2 and square root of 2's cancel, and we're left with 5. So that tells us that A is 5, one of the legs is 5, and the legs are the same. And you can double check yourself. If this leg is 5, then to go back to the hypotenuse, you take 5 times square root of 2, and you ended up with 5 square root of 2. So you can always go back and double check yourself. So anytime you're given the hypotenuse, in a 45, 45, 90 triangle, you can divide by square root of 2. Okay, let's look at, still on B2 at problem 8. We're given the hypotenuse. Okay, anytime you're given the hypotenuse, take the hypotenuse and divide by square root of 2 to get your leg. There's nothing to cancel here, but we can simplify. You cannot leave a radical in the denominator. Somewhere along the line, someone said that's a bad thing, and so you have to get rid of the radical in the denominator. How do you do that? You multiply it by itself. Whatever this is, multiply by square root of 2 by itself to get rid of the radical. Whatever you do in the denominator, you have to do in the numerator, because essentially you're multiplying by 1. So now, in the numerator, we would have 13 square root of 2. The denominator, square root of 2 times square root of 2 is square root of 4. Keep going until that radical's gone. So numerator still is 13 square root of 2. Square root of 4 is just 2. So you can leave it as this, your legs as that, or the book goes ahead and divides out these numbers. 13 divided by 2 is 6.5. So they leave each leg to where each leg is 6.5 square root of 2. It's okay to have a decimal and a radical. You could have also left it in the form of 13 square root of 2 over 2. That's not wrong. Either form is correct, they're just different forms. So either way of these.